When we think of mass extinctions, we usually think of failure. We imagine worlds destroyed, creatures gone forever, and entire chapters of history erased from the planet. But when scientists look deeper into the fossil record spanning more than 540 million years, they uncover a remarkable paradox. Every time life seemed on the verge of losing, it found a way to begin a new chapter. The history of life is the story of those that changed when the world changed. We often assume that the dominant species will be the ones that survive the longest. The giant coral reefs that once dominated ancient oceans disappeared. The powerful armored animals that once ruled the seas became extinct. Non-avian dinosaurs governed the planet for more than 160 million years, far longer than the entire existence of humanity many times over, yet in the end, they could not survive a fateful day 66 million years ago. Animals capable of feeding on many different kinds of food, organisms able to endure low oxygen environments, food shortages, or extreme temperatures. But when disaster arrived, those very ordinary traits became advantages for survival. When environments remain stable, evolution often produces increasingly specialized organisms. Imagine a species that can live only within tropical coral reefs. If ocean temperatures change or the reefs disappear, its entire survival strategy collapses. During the planet's darkest days, flexibility becomes more valuable than strength. What is astonishing is that after every wave of destruction, life does not simply recover. The former rulers disappear, and new opportunities emerge. Groups of organisms that once lived quietly in the shadows suddenly gain the chance to flourish and shape the next world. In other words, mass extinction is both an ending and a beginning. And that is the first lesson of this journey. Life prevails because it always leaves survivors behind. No matter how great the catastrophe, there are always organisms flexible enough to endure. But this paradox has only just begun to reveal itself. Around 444 million years ago, life faced its first crisis large enough to push the entire planet to the brink of collapse. At that time, nearly all complex life existed in the oceans. The land remained barren, with no forests, no large animals, and no ecosystems capable of replacing the seas. And then, disaster arrived. As the supercontinent Gondwana gradually drifted toward the South Pole, enormous ice sheets began to form. Earth entered a severe ice age, and sea levels fell by tens of meters. That is exactly what happened to the shallow marine ecosystems of the Ordovician period. Those shallow seas were the center of life. Trilobite swarms wandered across the seafloor. Ancient bryozoan forests filtered food from the currents. Creatures resembling modern lamp shells, known as brachiopods, covered the ocean floor. Primitive cephalopods such as Orthoceras, with their long, straight shells that could reach several meters in length, were among the most formidable predators of their age. But then the seas retreated, and habitats that had remained stable for millions of years disappeared within a very short span of geological time. The result was that approximately 85% of marine species vanished. This was the first mass extinction in the history of complex life on Earth. Yet, something strange began to emerge when paleontologists studied the fossils that remained. Why did some species survive while others disappeared? If strength had been the deciding factor, large predators such as Orthoceras should have prevailed. Some deep-dwelling brachiopods survived. Certain small mollusks capable of adapting to a wide range of temperatures also made it through the crisis. Species perfectly adapted to their current environment are often more vulnerable when the world changes. In contrast, species capable of tolerating a wide variety of conditions tend to have a greater chance of survival. What would happen if just one of those essential factors disappeared? Its entire survival strategy would collapse. But a species capable of living in many different environments will always have alternatives. They were the architects of the new one. And this is also the first survival lesson Earth leaves behind after more than 500 million years of evolution. Flexibility is often more important than dominance. But if you think cold was the greatest threat life ever faced, history still holds an even more terrifying chapter ahead. Because in the next great test, the thing that disappeared was not a habitat. It was something that nearly every complex organism needs to survive: oxygen. Between approximately 372 and 359 million years ago, during the late Devonian period, Earth was still teeming with life. The oceans were home to some of the most complex ecosystems ever to exist. Ancient coral reefs stretched for thousands of kilometers. Armored fish, such as Dunkleosteus, one of the most fearsome predators of its age, dominated the seas with jaws capable of crushing prey with tremendous biting force. Schools of lobe-finned fish and lungfish were beginning to experiment with the first evolutionary steps toward life on land. This phenomenon is known as oceanic oxygen depletion, or anoxia. What caused this catastrophe? Scientists believe that as the first primitive forests expanded, they altered the planet's nutrient cycles. As a result, enormous regions of the oceans gradually became suffocating. What happens to an ocean when oxygen disappears? The largest organisms, those requiring the most oxygen, were among the first to suffer. Ancient coral reefs that had once been centers of biodiversity began to decline. Many groups of reef-building organisms vanished from the fossil record. Ecosystems that had endured for tens of millions of years collapsed. Giant armored fish such as Dunkleosteus, symbols of power in the Devonian oceans, also became extinct during this period. Another example can be found among the lobe-finned fishes of the Sarcopterygiae group. They were not the rulers of the Devonian seas, yet some of their lineages survived the crisis. The winners of that age left no descendants for the future, while some of the less remarkable creatures became the ancestors of nearly every land-dwelling vertebrate alive today. A species does not need to be the strongest to survive. It only needs to endure longer than the apocalypse. That is the second survival lesson in the history of life. Ahead lies a catastrophe so immense that every previous extinction appears like a small crack on the surface of history. A day when life truly came close to complete defeat, the Great Dying. Up to this point in the story, life had survived two enormous catastrophes. One when the oceans shrank during an ice age, and another when the seas gradually lost their oxygen. But nothing could prepare the planet for what happened around 252 million years ago. Paleontologists call this event the Permian-Triassic mass extinction. But it is also known by another, far more terrifying name, the Great Dying. Imagine this. If 100 marine species existed before the catastrophe, only 4 to 10 remained after it was over. Approximately 90 to 96% of all marine species vanished. On land, around 70% of vertebrate species became extinct. What happened? In the region that is now Siberia, one of the largest volcanic eruptions in planetary history began. Not for a few days or a few years, but for hundreds of thousands of years. Lava covered more than 7 million square kilometers. Large areas of the oceans became dead zones. Worse still, geochemical studies suggest that in some places, anaerobic bacteria flourished and produced hydrogen sulfide, a toxic gas with the smell of rotten eggs. Seas that had once been filled with life became poisonous to the very organisms living within them. If animal groups that had succeeded for hundreds of millions of years all failed, then who survived? Part of the answer lies in a little-known creature called Lystrosaurus. It was not the most terrifying predator. It was simply a plant-eating animal roughly the size of a large pig. With a low-slung body, short legs, and a fairly ordinary appearance. Yet after the mass extinction, Lystrosaurus fossils appeared everywhere. In some regions, more than 90% of all vertebrate fossils discovered belong to this species. Why? Because Lystrosaurus possessed exactly the traits needed in a post-apocalyptic world. Its body was not excessively large, so it required less energy. Its diet was not highly specialized. Its ability to burrow helped it avoid the harsh climatic conditions at the surface. The most specialized organisms are often the first to disappear. The most adaptable organisms tend to have a greater chance of survival. Do you notice something? If this catastrophe had been only slightly more severe, many scientists believe that the remaining vertebrate lineages might have been completely wiped out. From the fragments that remained, a handful of small lineages began to recover. But in the new world forged from the ashes of the Great Dying, they were preparing to seize the greatest opportunity in the history of evolution. Were the survivors truly lucky? Or is there a pattern behind their success, one that life has repeated for hundreds of millions of years? Paleontologists have spent decades searching for the answer. They have compared thousands of fossils from different groups of organisms, from the Ordovician and Devonian extinctions to the Permian event. Earth's champions of survival are almost never the strongest creatures. They were not the largest predators like Dunkleosteus. They were not the organisms that dominated the oceans like trilobites. Nor were they the most successful specialized species of their time. Instead, most survivors shared a set of very ordinary traits. They were usually smaller. They could eat a wider variety of foods. They reproduce more quickly. They could live in a greater range of environments. And most importantly, they required less energy to survive. Why does that matter? When ecosystems are stable, larger species often have the advantage. They control food, resources, territories, and compete more effectively. But when catastrophe strikes, everything is reversed. Food sources disappear. Climates change. Species that depend on a single food source often face great danger when environments change. If that food source disappears, they are left with almost no alternatives. In contrast, omnivorous species have more opportunities to survive. Another trait that frequently appears among survivors is a broad geographic range. If a species exists in only one location, a local disaster can erase the entire species. But if it lives across multiple continents or a variety of environments, the chances that some populations will survive become much greater. And there is one more factor, perhaps the most important of all: adaptability. Do you notice what all the survivors we have discussed have in common? They all share one defining characteristic. They are not dependent on a single state of the world. And that may be the greatest secret the history of life has ever revealed. For more than 540 million years, Earth has rewarded those that adapt best. Strength may help a species dominate an era, but the ability to change is what allows a lineage to endure across many eras. That is why crocodiles still exist while many of their larger relatives disappeared. Horseshoe crabs have survived with little change for more than 400 million years. And the tiny ancestors of mammals quietly persisted alongside the giants that ruled the planet. Adaptation is more important than dominance. That is not merely a lesson of evolution. It is a principle tested through hundreds of millions of years of catastrophe. But what is fascinating is that this principle does not only help organisms survive. Sometimes it allows the underdogs to rise and dominate the entire world. And there is no clearer example than the group of animals quietly waiting for their opportunity after the Great Dying. If you traveled back in time to around 220 million years ago, you would not see dinosaurs ruling Earth. That may sound difficult to believe. When we think of the age of dinosaurs, we usually imagine giant creatures dominating the planet for more than 160 million years. But throughout much of the Triassic period, dinosaurs were only a relatively small group of animals, living alongside rivals that were far more formidable. At that time, the world belonged to other reptilian groups. There were giant predators, such as Postosuchus, reaching lengths of up to 5 meters and occupying the top of the food chain. There were armored herbivores such as Adasaurus wandering across the arid plains. Numerous ancient archosaur groups occupied most of the major ecological niches on land. Meanwhile, some of the earliest dinosaurs, such as Coelophysis and Eoraptor, were relatively small. They did not dominate in numbers, yet the history of life has repeatedly shown that the future does not belong to those who are winning today. Around 201 million years ago, Earth entered another crisis. This was the Triassic-Jurassic extinction event, the catastrophe that marked the boundary between two major geological periods. Over a relatively short span of geological time, millions of cubic kilometers of lava erupted onto the surface. Vast quantities of carbon dioxide poured into the atmosphere, and global temperatures rose dramatically. The climate became unstable, and many ecosystems on land and in the oceans began to collapse. The reptilian groups that had dominated for tens of millions of years began to disappear. Many of the larger relatives of ancient crocodiles suffered severe declines or became completely extinct. Apex predators that had once seemed invincible no longer appeared in the fossil record after this event. But when the rulers disappear, what happens to the empty spaces they leave behind? That was the moment dinosaurs stepped onto the stage. What is fascinating is that dinosaurs did not appear after the catastrophe. They already existed. They were simply waiting for an opportunity. Scientists call this concept an ecological niche. When a species becomes extinct, its food sources, territory, and ecological role are left vacant. The organisms that survive gain the opportunity to expand and evolve into those empty spaces. New lineages emerged at an increasingly rapid pace. Within only a few tens of millions of years after the extinction, dinosaurs diversified into an extraordinary variety of forms. From a relatively small group of animals, they became the most successful land vertebrates in history. Their upright limbs, positioned directly beneath the body, allowed them to move more efficiently than many other ancient reptiles. A more advanced respiratory system may also have helped them adapt to changing environments. Most importantly, they were flexible enough to take advantage of the new world that emerged after catastrophe. Do you recognize the familiar pattern? In the Ordovician, organisms capable of enduring harsh environments survived. In the Devonian, species adapted to low oxygen conditions survived. In the Permian, organisms that required less energy survived. And now, after the Triassic extinction, a group of animals that was not yet the strongest, but flexible enough to seize an opportunity, became the winner. The third survival lesson of Earth begins to reveal itself. Catastrophe does not only destroy. Every mass extinction is like history pressing a reset button. The old rulers disappear, new rules emerge, and sometimes the creatures once living at the margins become the leading characters of the next age. But the story contains an even greater paradox. After more than 160 million years of ruling the planet, dinosaurs seem to be the perfect example of evolutionary success. No group of land animals had ever dominated for so long. Yet the very principle that raised them to the summit would also be the principle that brought them down. Because somewhere in the future, another catastrophe was approaching. And this time, not even the dinosaur empire would escape it. For more than 160 million years, dinosaurs ruled Earth. That span of time is so vast that it is difficult to comprehend. Tyrannosaurus rex lived closer to our own time than it did to the earliest dinosaurs that appeared after the Triassic extinction. Giants such as Argentinosaurus weighed tens of tons, while predators such as Tyrannosaurus stood at the top of the food chain. From the perspective of any creature living at the end of the Cretaceous period, the dinosaur empire must have seemed destined to last forever. But the history of life follows a relentless rule. No empire is eternal. Around 66 million years ago, an object approximately 10 to 12 kilometers in diameter hurtled toward Earth at a speed exceeding 70,000 kilometers per hour. It struck the shallow seas near what is now Mexico's Yucatan Peninsula, creating the Chicxulub crater, roughly 180 kilometers wide. In the instant of impact, the energy released was equivalent to billions of atomic bombs. Global temperatures plunged. Photosynthesis nearly came to a halt. This is what makes the KPG extinction so extraordinary. The asteroid did not directly kill most of the organisms on the planet. It destroyed the life support system of the entire world. Once the foundation collapsed, even the strongest creatures could not survive. Fossil evidence shows that approximately 75% of all species on Earth disappeared. Every non-avian dinosaur became extinct. Giant marine reptiles such as Mosasaurus vanished. Enormous flying creatures such as Quetzalcoatlus were never seen again. So who survived? By conventional logic, we might assume that the largest, strongest, or most intelligent creatures would have been the most likely candidates. Yet the survivors were often so small that they were almost unnoticed. Consider the ancestors of mammals living at that time. Most were only about the size of modern mice or squirrels, and that turned out to be an advantage. Many species could burrow underground, where they were protected from extreme temperatures and the fires raging across the surface. They fed on insects, seeds, carrion, and almost anything else they could find. They did not require enormous food supplies to sustain their bodies. They could endure long periods without eating and survive in freshwater environments that were less severely affected. Many turtle species also survived the catastrophe thanks to their ability to withstand harsh conditions and their low metabolic demands. Even more astonishing is this. If the asteroid had not struck Earth on that day, dinosaurs might very well have continued to dominate the planet for tens of millions of years more. And if that had happened, would mammals ever have become the dominant group on Earth? Would primates have emerged? Would humans have existed at all? In a sense, our existence today began on the day an asteroid brought the dinosaur empire to an end. But that is only the beginning of the story, because the tiny creatures that survived the apocalypse were not merely going to endure, they were about to transform the history of Earth completely. Before the asteroid impact, mammals had already existed for a long time. Species such as Didelphodon and Eomea were only about the size of mice or small weasels. They hunted insects, fed on seeds, dug burrows, and were primarily active at night to avoid predatory dinosaurs. In a world dominated by giant animals, such as Tyrannosaurus rex, Triceratops, and Edmontosaurus, mammals seemed little more than insignificant supporting characters. Then the apocalypse arrived. Survival was only the first step. What happened afterward was truly remarkable. Within just about 10 million years after the extinction event, mammals diversified at an unprecedented rate. Some evolved into large herbivores, others became predators, some returned to aquatic environments and eventually gave rise to whales. Others learned to glide among the branches and became the ancestors of primates. This was one of the most spectacular evolutionary radiations ever recorded in the fossil record. Around 55 million years ago, the first primates appeared. They possessed forward-facing eyes that allowed them to judge distances more effectively while moving through trees. Tens of millions of years later, some primate groups evolved into apes. Then, from small populations in Africa, species belonging to the genus Homo emerged. Finally, around 300,000 years ago, Homo sapiens entered history. When we look back across this entire journey, an astonishing truth begins to emerge. Humans are not only the product of evolution, we are also the product of catastrophes. If the Ordovician extinction had unfolded differently, many marine lineages might not have survived. If the Devonian extinction had completely wiped out the lobe-finned fishes, land vertebrates might never have appeared. If the Great Dying had been only slightly more severe, the distant ancestors of mammals might have vanished forever. And if the Chicxulub asteroid had missed Earth, there very likely would never have been humans. That is the greatest paradox of this story. We often view extinction as a period. But many times, it is also a comma marking the beginning of an entirely new chapter. From tiny mammals living beneath the feet of dinosaurs eventually emerged creatures capable of building cities, decoding DNA, and looking back into the distant past to understand their own origins. After journeying through the great mass extinctions, are these events merely random accidents of history? Or is there a deeper principle behind them, one that has quietly shaped all life on Earth? The fossil record has been answering that question for more than 500 million years. Strength is not the deciding factor. Size is not the deciding factor. We begin to realize that the 5 great mass extinctions are 5 chapters of the same underlying rule. The source of the next crisis may not come from an ice age, an asteroid, or a supervolcano. It may come from the very species that learned how to understand that entire rule. Thank you for staying with WUFO Space until the very end of this journey through the vast universe. If you found this video interesting and insightful, don't forget to like, share, and subscribe to WUFO Space so you won't miss our next cosmic adventures. Your support means the world to us and fuels our passion to keep exploring the wonders beyond.